Hey guys, welcome back to another video. So today I'm going to be explaining a simple linked list in C++ which takes in a user input, okay? So for this simple linked list, the data we're going to be using will be an int data. So it's going to be taking an integer data, okay? So we're going to include our input output stream, which is so we can have our cout, okay? So we can have cout and all that, and most of the functions here are included in the library of iostream. We're going to be using namespace std, so we don't have to write this in front of every line of code. Okay. And so we're gonna have a struct defined as node, okay? So a node is basically a memory, like what's it called? Allocated memory in a node is basically a node basically, let's just say let's have a box here. Let's have a line between these two boxes, okay? So a node basically contains a pointer address and the data correlates with the pointer address, okay? So a node stores in the pointer address, which is node. Okay, that's and then like node next is also is going to be pointing to the next node. Okay, and then int data will be the data that's inside the pointer address, which is the node, which is the pointer is the node basically. Okay, and then we're gonna have node, and then we're gonna have and then and the node is gonna be int value. Fuck. So node is gonna have an int value, okay, and then it's gonna what's it called parameterize. This is basically a parameterized constructor for the struct node. So data will have value. Value is basically something that's gonna enter. This is how we're gonna enter data into the. So this is basically the param. This is gonna be the parameterized constructor, which is gonna take an integer value and then it's gonna allocate the value to data. So data will equal to value, and next is going to be a null pointer. Okay. The reason it's null pointer is because like it's gonna be an empty node basically, which is null. Okay. An empty node is basically null, which has no point of memory address, no it could have a memory address, but no data and no memory address basically. That's a null pointer. Okay. So we're gonna use a class called linked list. We're gonna have a private called node head, this is where we declare the pointer. Okay, this is where we declare the pointer address for the head of the linked list. The head of the linked list is basically the start of the linked list. This is where the linked list starts from, the pointer address from which it starts from. For example, let's say let's call the memory address x1. That's basically the head, and the memory address x2 or x3 will be the next pointer address. Okay, so that's just like describing it in simple terms, in terms of like x. Okay, and okay, our public variables will have our what's it called? Our constructor, which is linked list, which will have head as a null pointer. So head will be a null pointer, which is a memory address. A null pointer is basically an empty address, basically. Okay, let me just confirm that. I'll be all over the place with some. So a null pointer is a constant for indicating to the pointer does not point to any valid object or valid or function. So it doesn't point to anything, it's just there, okay? All right. So we just have our node value, okay? We're going to use a pointer, like the pointer is basically the star. It's going to be this is our insert, this is our void insert function, okay? So we're going to be inserting into the linked list, okay? So we're going to have a node, right? The node is gonna we're gonna call it a new node. Basically, this is declaring a new node, like temporary. It's gonna be like a temporary node, okay? Or call it a new node. A new node is it's gonna take in the value. So new node will have will be allocated with the value, okay? Which is the value we're inserting, okay? And new node dot next. So basically, what we're doing here is like, let's just say we had the head value here, right? And then new node is here. We're just trying to insert new node into our to our list right here, okay? So what we're saying is like, okay, new node already has a value and it's called new node, okay? What we're gonna do is new node dot next. So the new node dot next, the next value of the new node will be head. So head instead of being here will now be here to be here next, okay? And then the new head that was supposed to be here will be new node. So new node will be at the first of the link to be the first what's it called? The first pointer in the linked list or the first object in the linked list, and the second will be the previous head value. Okay, so that's how you insert into a linked list. Okay, and the display function in the linked list is basically going to be printing out the linked list. Okay, so what it says is, well, no, this is a temporary pointer to hold head for. So temporary pointer, let's just say the temporary is up here. This is where the linked list is. Like it's linked list, like let's assume it's like a chain. Okay, and node temp equals head. Okay, so the temporary value is head. Okay, while temp is not equal to null pointer, so until we don't get to the point where like there's no empty pointer in our linked list, or there's no pointer at all in our linked list, which is a null pointer. Okay, then we gotta see out temp data. So what this means is we're gonna console output the data value of every pointer in our linked list. Okay, or every chain, or every, like, what's it called, part of the chain, link chain in the linked list. Okay, so the reason we do temp dot data is like we don't have to print in the memory address. Okay, we don't want the memory address of a pointer. The main point of a memory address is to hold the data, right? So we're gonna be printing out the data, and we do that by using the arrow pointing to the data. Okay, and that's how we do it. This is what we want to print. Okay, the integer values. Okay, and this is just for space. This is just an empty what's it called, bracket, or you could call it a quotation mark. And then our temporary value is equal to temporary dot next. So our temporary value that was holding our, let's just say, our head value here, now will go to the next value. Okay, now it's going to be printing out the next value. Okay, that's what it's going to be, like temporary equals, instead of just pointing to the head now, because temporary was pointing to the head in the beginning, right? The temporary is just going to do, and this is going to keep running, because it's going to go temporary dot next, temporary dot next, temporary dot next, and until it prints out the whole array, until, I mean, the whole linked list, until we get to null pointer, and then it will terminate the while loop, and we're gonna have a cout end, which is to skip a line. But this is how we print out the linked list. Okay, and let's just say we want to remove a node from the linked list. Okay, and to remove a node from the linked list, we have to iterate through the linked list to find out the point we're looking for, and then delete that, what's it called, pointer or data in the pointer. Okay, so this is how we do it. We're gonna have a node called temporary, which is gonna hold uh temporarily temporarily okay, I'm gonna spell it, but temporarily hold linked list values. Okay, and then now it's gonna start off with the head value. Okay, which is the beginning of the linked list basically. And then we're gonna have a node, the previous value, which is null pointer. So the previous value before the head is not existent, since there's nothing before the first value, so it's going to be a null pointer. Okay, doesn't exist basically. Null pointer which doesn't exist. Okay, kind of messed up in the beginning of the video. I told you guys were like, it could be a pointer that's like, that has no value in it, but null pointer basically means like it's null. Basically, the pointer does not exist, like zero. It's a zero pointer basically. That's what they call it, a null pointer. Like it's a zero pointer, so like there's no value in it whatsoever. But yeah, so if the head node itself holds the value to be deleted. Okay, so let's just say, like, if the head itself was the value which we're deleting. Okay, which means once we delete the head value, we gotta rearrange the list to a point where, like, we gotta point the next value the head value if we're deleting the head value. Okay, and how we do that is like to check first of all if the temporary not equal to null pointer, and temporary dot data equals to the value we're deleting. Okay, and then what we're gonna do is going to say head equals to temporary dot next. We're gonna put the next value. So temporary is already like pointing ahead already. Okay, the temporary the next will be the second value in the linked list. Okay, so once it points to the second value in the linked list, like the head points to the second value in the linked list, so now the new head of the linked list is the second pointer. It's gonna delete the temporary value. Okay, temporary value was already pointing to the head, so yeah, and then it's gonna return. But let's say we have to find the node to be deleted, and keep track of the previous node. So now we have to like figure out which node we want to delete from the linked list. Now we gotta transverse through the linked list to figure out which. No, transverse basically means go through the linked list to find out which node we want to delete. Okay, so while temporary is not equal to null pointer, and temporary is what's called temporary data is not equal to value. So while it's not equal to value, it's gonna go through the linked list. Okay, so it's gonna keep transversing, transversing, transversing until it finds where the value is, and then we're gonna go to the if statement. Okay, if the temporary value is not equal to null point, then return. If not, it's gonna be say previous dot next to be the previous value. What do you call it? The previous dot next is basically the previous value. It's gonna be like previous dot next equals to temporary dot next. Dot next is like basically like the arrow to the next, like the next value to after temporary, which is like currently after transversing, we won't know where it is, but whichever wherever the value is, basically, it's hard to tell. And and then once we figure out if this value is found out, the value we're trying to find out after the while loop has traversed, it's just gonna delete the temporary value. Since like the temporary value, like the temp node basically jumps between the nodes in the linked list. So once it finds out which node, which value node we want to delete, the temporary just deletes it. It stores it in temporary, deletes it, and then relinks the linked list again. So this is how we remove a node from a linked list. Okay, and function to delete this deletes the entire linked list. This is done by transversing through every pointer in the list and then deleting every pointer. Okay, so for example, node current is basically the head, or which was temporary earlier up here, but this we just call it current head, and then node next equals to null pointer. Okay, so like the next, so this is just like a way of like initializing the next value. Okay, and then what we're gonna do is gonna say well, current is not equal to null pointer, next equals to current dot next. So this is not how, this that was initialized now had the value next equals to current dot next, which means the second value in the linked list. Okay, then it's gonna delete current, then current equals next. Okay, so now current the head equals to the next value that was the second value. I remember I told you guys the second now link that next is linked to the second value in the linked list. So current is equal to linked list, okay? The second point in the linked list, okay? So current equals to next, and then it's gonna delete. Then it's gonna keep doing this over and over and over and over and over again until it deletes the whole linked list. So yeah, until head equals to null pointer, then the whole this is cleared out. And then once it gets to the last value, it's just gonna call it head null pointer since the while loop would have been over by then. But yeah, and then the structure is basically to deallocate the memory space that we allocated the linked list in, okay? Which would just delete this basically, okay? So just clear it out, and yeah, I left some comments, you guys can read it out, but yeah. Now the main function is it's like a user interface, okay? So we're using a do while loop which has two variables here which are integers, which is the choice and the value we're inserting. Since the value is here, which is that's the data we're going to be inserting, which is integer data, okay? That's why we just put it with integer, okay? So the do while loop says these are the linked list operations. Insert an element, delete an element, display the list, and exit, enter your choice. And then we're going to console input the choice. Okay, we're going to insert the choice here. Insert our choice to play with the linked list, I guess. Okay. So we're going to be using a switch, which is easier since whatever choice we put in would be like, for example, if we choose choice one, select one to be case one, select two would be case two, select three, case three, so forth and so on. Okay. And if we, what's it called? If we select four, which is exiting, it's just gonna terminate the while loop since the while loop keeps on running as long as choice is not equal to four. Okay. And then console input into the value to insert console input value cout, and they'll list on insert value. Then we break, of course, because we have to break from the switch. Every time we insert, we break from the switch, and then it goes back to the do while loop up again here. Okay, so it's the same thing here. Case two, enter the value to delete. It says value, but key point here is list dot insert value, list dot remove value, list dot display value, and yeah. So yeah, I'm gonna just run the program now. I hope you guys can see the code. I'm gonna just do this for once. Just I'm just zoom in so you guys can see clearly. I'm just slowly show you guys the code. This is clear news. So I'm gonna run the code. So I'm gonna just say insert element first. Let's say I insert two. As I insert element again, let's say I insert six. So insert element again, say insert one. Insert element again, insert nine. Insert element again, insert zero. Now I'm gonna print out the list. I'm gonna say print out the list. So three is our choice for that. So we have our list printed out here, 0916. You notice it's inserting the list in a backwards motion, which is like the last value entered will be the first value printed out. So like a stack basically, okay? So this is 0, 9, 6, right? 6, 2, okay? Now we're gonna delete an element, okay? Delete. Actually, it's gonna be right 2 here. Which value do I want to delete? Let's say we delete 6. I'm gonna print out the blank list. So here you go. Then I'm gonna say yeah, I'm just gonna say exit. So you can tell here that we deleted a 6, like here before we had 09162. Now we have 0912. Here we have 09162. Let me just say 4 to exit the program. And yeah, thank you for watching this video, guys. I'll see you guys in the next one.